Hooray! Welcome to the channel. My name is Victor and I'm going to be your anchor for this training. So this is going to be the CompTIA Security Plus certification. So if you want to take the Security Plus certification, it's called the SY0-701 exam. So stick around. I want to talk about everything you need to be aware of to be able to write and pass the certification exam. So every certification is going to have what we call a curriculum. So I have taken quite a lot of CompTIA certification. I think just yesterday I stumbled upon a 1998 study guide by Cybex in my shelf. I'm going to talk about it in another series. So CompTIA have been around for quite a while. Very well-known certification body. So let's look at that very intermediate, or will I say entry-level certification program for security analyst. Now the curriculum is something about 21 pages. So if you want to pass the certification exam, the idea is you should understand every item in the curriculum. So you can be a security analyst, you can be very hands-on, you can understand these terms, but if you don't exhaust the entire curriculum, then you might not be able to pass the exams. So the Security Plus certification exam is going to be for 701, is going to be retiring sometime next year. We're going to have a new version. So if you want to take this exam before sometime around October, November next year, then stick around and let's go through the curriculum. Now it's called the 701 exam. Now let's talk about the exam. So the exam is just one exam. So if you pass one exam, then you are sure to be able to get this certification. Now most exams have multiple exams to be able to pass them. Like the CompTIA A+ exam, you need to pass 2 exams to be able to get the A+ certification. For the Security Plus certification exam, you just need to pass 1 exam. Now the question is, how many questions do we have on the certification? So it's going to be a maximum of 90. So we have maximum of 90 questions for the exam. So I've written CompTIA certification exams. Most of the times for entry-level certification, you will get between 82, 83. Maximum is going to be 90. Now, for most CompTIA certification exam, you're going to start the exam with performance-based questions. So you're going to start with around 4 or 5 questions that are going to be performance-based questions. So those performance-based questions are going to be drag and drops. You're given a scenario, you are given some diagrams. You want to be able to understand the concept. You want to drag, you want to drop, say, okay, this is the correct way to do something, this is how to configure something. Just diagrams, drag and drop, performance based. They also have multi-choice questions. Multiple choice questions are where you have a question and you're going to have options to pick 1 or to pick 2 or to select 3. Now that's about the questions you have for the exam. Now, what is going to be the length of the test? Like I said, 90 minutes. Now, if you've spent between 0 to 2 years, and you understand, have a good grasp of security fundamentals, right? Then you can take the certification. Now, if you have some hands-on technical experience, you can pass this exam. Yes, this exam is not very handy. That's why some persons that go through the entire curriculum, go through the entire content. I have a comprehensive playlist on Security Plus 701 on my channel. Do well to subscribe. Check out the content. It's a 17-part series on 701. You can still pass the exam. So the exam is an entry level that tests your knowledge about security concepts. Now let's look about skills. So what kind of skills are you going to be getting when you complete this certification program? So can you assess security posture and recommend solutions? Now we have a company that have so and so vulnerability or so and so issues within their enterprise, either on their web applications, on their enterprise endpoint systems, or on their mobile systems, or on their cloud applications. You want to be able to assess the current state, the current posture of the organization, and be able to say, okay, this is what I'm going to recommend for them. Now, can you be able to monitor and secure hybrid environments? So what do we call hybrid environments? Hybrid environments are environments that are not just in one type of area. That's to say that we're not just having something that have to do with our physical devices. We're not just having something that have to do with mobile devices. We're not just having something that have to do with web applications or cloud. So when we say hybrid, we mean that it encompasses all of these areas. Now, do you understand governance, risks, and compliance? So that's what we call the GRC. So from the last certification, 601-701, CompTIA have imputed quite a lot of concepts that have to do with cloud, quite a lot of concepts that have to do with GRC, because this is an evolving field and we want entry-level certification holders to be able to understand and have the skill set. So you should be able to understand what is governance, how do we do control, how do we do quality assurance, how do we ensure that from the very peak, from the very top of what the C-level executives want to be the security posture of the organization, we can, through policies, guidelines, principle, we can actually enforce that. So that's what you call governance. So of course, risks and compliance. Then can you be able to identify, analyze, and respond to security events, right? So you have some little concept about SEM on this certification exam. So those are some of the skill sets that you're going to be tested upon. Then you want to be able to understand policies and guidance. So this is still part of governance. Now, yes, CompTIA talks about, because this is from the guide, right? So you don't want to have yourself where you are focused on just brain dumps. Yes, brain dumps will help you understand some concepts, but you want to ensure that you fully grasp, you fully understand what the curriculum wants you to understand. You typically don't even need to go through any exam dumps and you can still pass, provided you go through the concepts, provided you go through the scenarios, provided you go through the case studies, provided you can understand what you are meant to understand. Just like you're going to see in every curriculum, you're going to be hearing things like compare and contrast various types of security controls. So here, the idea is that CompTIA wants you to be able to define, to be able to understand, and be able to compare. Here, you're not meant to be able to implement any of this. In higher certification exams, like maybe pen test or let's say Security X or CISA, you might be told to be able to implement. So, but for here, you're just told you should be able to compare and contrast. So once, for this concept, once you can understand them, you can compare, you can differentiate them. For the exam, any question that is going to come within this axis, within this area, you are going to be able to pass. You see this particular aspect, summarize fundamental security concepts. Now you're going to see some things, some aspect of the curriculum is going to be saying explain, whereas some aspect is going to be saying, this says explain, this says compare and contrast, this place says explain common threat vectors, this place says explain various types of vulnerabilities, giving a scenario, analyze indicators of malicious activity. So we're saying that if we have an issue, if we have a scenario, can you be able to pinpoint to say this is a ransomware or this is a Trojan, so this is a worm, this is a spyware, right? So you see the different aspects of the curriculum want to be able to ensure that you fully understand the concept. Now any certification exam where you see compare, contrast, define, summarize, it tells you it's an entry-level certification. Though any certification exam where you see implement, where you see deploy, right, it tells you that it's an intermediate or an advanced level certification exam. Now, understand that this 701 exam is always going to be reviewed from time to time. Most certifications from CompTIA and most bodies, if you hold them, it's going to be lasting for an average of 3 years. Now, the certification exam have 5 modules, have 5 areas. If you check the summary of the certification, you're going to see that it covers 5 areas, which is general security concepts, threats, vulnerabilities, and mitigation. if it's the pen test plus certification exam, it's not going to stop at threats and vulnerabilities. It's going to also talk about penetration testing. But this is an entry level certification exam, so you understanding threats, you understanding vulnerabilities, and how to mitigate some of all of these will suffice. Now you have security architecture, security operations, and of course security program management and oversight. Now if you see, you're going to see that from the 701 exam, a lot of weight is given to security operations. So it's trying to get towards SOC concepts for you to be able to manage situations that arise within your enterprise. So we will write on and look at each and every one of them. So the guy that is the least in the exam. So if you're preparing for the certification exam and you only know security concept, you can define, you can differentiate, you can understand that. I can bet you that this is just 12% of the exam. So you can know all of this. If you fail most of the questions that are coming from security operations, then it's going to be difficult for you to pass the exam, right? So general security concepts, security controls. Now, these security controls, you want to be able to compare them, you want to be able to contrast them, then you want to be able to see their types. So if I have a situation, what are the categories of controls I can have? So you have technical, managerial, operational, physical. So technical is going to be all of those controls that we will typically implement as cybersecurity analysts, using computing, using cryptography, using hashing, using all of those softwares and tools and applications. Managerial, those things we will do at C-level, at the level of guidelines, principles, policies. Then at operation, anything typically administrative that will help us manage our enterprise. Things like, let's say, let us have job rotation. Let us have people not having so much control. Let us have some kind of access-based control system that is role-based, right? Then we can have some kind of physical controls. Those physical controls where we're going to have things like dogs, things like doors, things like physical, what's it called, CCTV, things like fence, things like a barricade. All of these things are physical controls. Then don't forget, there are some controls that are both physical and technical. Yes. So imagine you implementing a CCTV camera system. Yes, it's a physical control. You can say, okay, I have a CCTV camera here, but it's also a technical control because you have video monitoring. You're going to have backups. You're going to have softwares implemented. Let's say you implement something that is going to check perimeter, through which you don't want somebody to exceed. Let's say you have a digital asset and you don't want somebody to exceed a particular point. You can use most CCTV systems to track that. So some controls can be physical and technical. So for your exam, you want to be able to know the different types of controls, the categories, differentiate them, contrast them, see how they also relate. Now, in all of these controls you have, some are going to be able to prevent, some will deter somebody. Let's say you have a notice at the entrance of a server room, and the notice says this place is under CCTV surveillance, or you are being monitored, or this place is only for IT staff. That kind of control is deterrent. It's just going to deter. It's not actually going to stop somebody from doing whatever the person wants to do. Then you have some controls that will actually just detect. They're not preventing, they just detect. They just tell us, like if you have a firewall, some firewalls might be able to just detect. Not all firewalls are going to prevent, right? Some will just detect. So if you have an intrusion prevention system that will not just only detect and say we have a possible threat, some will go as far as also stopping that particular threat. Then you have some controls that are corrective, compensating, directive. Compensating, for instance, when you have a control, imagine you having an access door. Aside having an access door to a server room to protect a physical enterprise, you also want to have multiple layers that will compensate if a control is not very strong, right? So that's what you call a compensating control. So any control that is going to help another control, you call it a compensating control. Now let's look at some fundamental security concepts. Now, these are concepts that you should be familiar with if you are preparing for the CompTIA Security Plus certification exam. So we have the CIA, very, very awesome concept that I've been on for quite a while. It's called the confidentiality, integrity, availability. So we say confidentiality where we want privacy. We want confidential. We say confidentiality when we don't want disclosure. We say integrity when we want to make sure that something is not tampered with, something is not pilfered, something is not adjusted, something is not changed, something is not altered. We want integrity. We keep a file and we want to ensure that that file remains the way it is. Then we want availability. Persons that should have access to stuff should have access to it. Then we say non-repudiation. The sender of a message cannot deny having sent a message. The receiver of a message cannot deny having received a message. So we implement controls to be able to keep track of who does what. So when you authenticate people, you want to give them access, then you want to be able to track whatever they are doing. So you also have the AAA, the AAA principle, which is authentication, authorization, accounting. So it's like saying authenticate people into a system, give them authorization, then do accounting. Try to know what and what that has been done. In the event something bad happens, we can tell who did what. Then for gap analysis, this concept has to do with we trying to look at in our policy, where are we heading to? So in cybersecurity, most of the times, everything starts from a policy. So a policy is going to tell what we want to be done, right? A guideline might tell how we should do it. A procedure is going to tell out step-by-step way to be able to achieve that. Now, a policy is going to be very high level. Now, if we have a policy that we want to ensure that we don't have a breach, like we have minimum just one breach in a year, or minimum one kind of threat or one kind of incident in a year, we don't want to exceed that. What's going to happen is that we are at a particular point now. So where we are now and where we intend to get to, that is what you call gap analysis. Now imagine you saying, okay, you want to ensure that every account within your system have MFA, have OTP, have what's it called, backup systems and all of that. All of these things are the things that you want to ensure that you have. But the question is, where are you currently? Right? So that is what you call gap analysis. And for zero trust, you want to ensure that you don't allow everybody in, right? You don't allow everybody in. You want to have some kind of checks. And there's what we call adaptive identity. In adaptive identity, we want to say that we're not just even going by rules. We want to try to adapt to make sure that even if somebody else is giving my username and password, there are several other checks that is going to be done to ensure that it is actually me trying to have maybe access to that particular account. So at times we call it context aware. We want to check other things like IP address, the location, several other things we want to be. Is it this particular device the previous person used to log into a system? That's where also machine learning comes in. So we don't just want to trust you because you provided username and password. So there are several other things that we want to check. We can also have some controls that are policy driven, right? Then we can have some kind of implicit where we have complete no trust, and have some trust zones where we trust some certain assets depending on the kind of controls that is being given. Then of course we can also ensure that we enforce these, have some kind of enforcement points. We can say, okay, between the users that are trying to access the website from this login page, we can enforce so and so policy. If somebody is trying to access through a mobile, we can enforce so and so policy. If somebody is trying to access through a VPN, we can enforce so and so policy. So you call all of those your policy enforcement points. Now, in cybersecurity, we can't rule out physical security. Now, we say that you can be trying to do a lot of technical controls. If you rule out your physical controls, then you might not even have any digital assets to actually protect. If you check Google data centers, more data centers by a lot of companies, even companies that have most of their protective systems or that have their digital assets physically, they have one form of physical control or the other, because you cannot say, okay, I have the best software, I have the best firewall and all of that, but access to that particular item physically is very, very porous. So you have bollards, you have vestibule, you have video surveillance, you have access badge, you have sensors. For your exams, in the curriculum explainer I have done, I have differentiated all of these items. For your exam, you want to be able to differentiate each and every one of these items. Then we also have deceptive and disruptive technology. So this concept you want to understand. In the past, I've created systems that implement honeypot, honeynet. So what do you call a honeypot? Let's use a Wi-Fi for example. If I want to deceive or do some kind of deception with respect to people not knowing that this particular Wi-Fi, it's not the actual Wi-Fi, and have a Wi-Fi name called internet service. Internet service is the Wi-Fi name. Now, if I create another SSID called internet service, what's going to happen is that, and keep it open, no password, people around will try to access it, and while they're trying to access it, I can now start checking, investigating whatever kind of actions they are taking. So you call that a honeypot. When we have multiples of these, you call it a honeynet, right? And of course, we can have a honey token to track the activities of these actions by the users. So that's going to be that for fundamental security concept. So you should have basic understanding of these items, because your questions are going to be scenario based and they will test your knowledge to see if you understand these items. Now, change management processes. Most of the times in tech, things don't go as planned because of lack of proper change management. Now, change management, we're just trying to say, okay, we want to go from point A to point B. So our business processes might be tampered with if we don't do that properly. So we might have different business processes. Our business processes can involve, let's say, buying, can involve selling, can involve logistics, can involve emails, can involve access to cloud platforms, can involve recruitment, all of the kind of things that we do regularly in our businesses. It can also involve approval process. Somebody wants to go for leave, that approval process. Somebody wants to purchase something, somebody wants to buy something, somebody wants to do logistics, somebody wants to onboard a particular team of staff. Typically, everything that has to do with the day-and-day running of a particular business, you call it business processes. Now, we need to understand that we do a simple impact analysis to check what is going to be affected if we change a process, a way we're doing stuff, to another way. Let's say, for instance, we will normally do recruitment via our website. What about if we now want to do recruitment via a third-party software, a third-party application, or a third-party vendor? That's a simple change. We need to do some impact in case something goes wrong. Then we need to have some kind of backup plan, right? If something does not go out well, how do we ensure that we still keep moving? Then, because there are also going to be some kind of technical implications, right? So some of these technical implications are going to be legacy implications, restricted activities, allow, deny list. We want to ensure that if we are doing any form of change within our enterprise, we have some kind of controls. Documentation is so crucial. Documentation is important. If you want to change how you do stuff from this way to another way, you might want to have a diagram. You want to have some kind of policies. Aside policy, you might want to have procedures. You also want to have version controls. You want to have This is how we do stuff. This is version 1. If something goes wrong, because at times you might have vulnerabilities associated with your systems and processes, right? Not technically, but you have a vulnerability because of how you do stuff. So if you have a version and that version have issues, then you can update that particular version. So version control is so crucial. So a version of a way something is done can be an issue. So we want to always update that. Then for general security concept, so we might need to understand cryptographic solution. There's a whole chapter dedicated to cryptographic solutions. So PKI, public key infrastructure, encryption, some of these tools, obfuscation, hashing, salting, peppering, right? Digital signatures, certificate. These are very important concepts you want to be aware of for the exam. So you should understand what is a public key, what is a private key, key escrow, anybody that's going to be involved as the middleman managing keys between who is encrypting and who is decrypting. You should understand cryptographic concepts. I have the Cisco Cyber Ops comprehensive training material on the channel as a playlist. I also have that for Security 701. There's a module dedicated to cryptography. So please try and check that up. Now in encryption, you have different levels to which you can do encryption. Are you doing simple file encryption or folder encryption, or are you trying to encrypt the entire database? Then you have encryption can actually be symmetric or asymmetric. Symmetric meaning that both the key used in encrypting and decrypting, what you call our ciphertext and plain text, both keys are same. In asymmetric, it's different, right? So for your exam in preparation, you want to have a list of symmetric encryption and the application. You want to have a list of asymmetric encryption and their application. Then we have tools. For tools, we have trusted platform module. So I also have hardware security module. So you implement these for systems where you want rock solid encryption down to the hardware. Like you see in most systems, you have encryption not just at the software level, not just at the folder level, but down to the PC. Let's say for instance for a PC down to the BIOS, right? And you have several kind of key management systems. For obfuscation, we're just trying to understand some different concepts, how obfuscation can be done. Obfuscation just means hiding stuff. Because when you do encryption, you want to hide so that people don't see the plain text. So plain text, my name is Victor. Ciphertext, AB72534, basically 200 characters. So in encryption, we are going from plain text to ciphertext. In decryption, we're going from ciphertext to plain text. In steganography, there's an application of cryptography. We're trying to say that we are hiding files. At times we call this hiding files. So there are several tools that can be used for hiding files. So you can do file steganography, image steganography, video steganography, audio steganography, and so on and so forth. So you also have tokenization and of course data maxing. I want you to ensure that you understand the difference between hashing, salting, peppering. Hashing, salting, peppering. Of course, digital signatures. How do we ensure that we have a mark on our digital assets? One way to also do digital signatures is through hashing. Certificate is going to validate the kind of encryption or the kind of hashing, whatever that we have done. And one way we can do that is by having a validation, is by having a certificate of what have been done. So that brings us to certificate authorities. So you have bodies, you have organizations that are what we call certificate authorities. If you tap on this, for instance, and you go to site settings, this is secured, certificate is valid. So you're going to see something like, so this is the SHA-256 fingerprint, this is certificate, this is the public keys. So if you see this stuff, public key, it tells you that it's an asymmetric cryptography that was done. There, you see, this is a certificate hierarchy. This is certificate field. So you have version here, you have serial number, you have signature algorithm, you have issuer, right? So I'm coming just a second. Okay, so if you go to issuer, so you see Google Trust Service. So the certificate authority for this particular SSL implementation that is done here is Google. So you have several. You have Komodo. You have quite a lot of bodies that do that are certificate authorities. You also have revocation list. That's so that every certificate is going to have some form of expiry date. So if it's expired, it's going to be revoked. Look at this one now, it's expiring January 19th, right? 2026, this is going to expire. So if this is not renewed, it's going to be revoked. Then you have root of trust, you have wildcard. Root of trust is going to be the, like you see this notebook lm.go. So this is the root, right? Then for wildcard, you're trying to say that you're protecting several subdomain names within a domain. So you can have notebook LM, you can have business.google.com, you can have several of that. So if you have a certificate that takes care of all of those subdomain names, you call it a wildcard certificate, right? So there are some certificates that we just secure only the root domain, right? So, but for wildcard certificates, they will protect all the subdomain names within, and they are more expensive, right? If you have a domain and you have something like blog.google.com, you have youtube.google.com, you have ceo.google.com, all of these are subdomain names. So if you have a certificate that secures all of them, you call it a wildcard certificate. Okay, that's all for the general security concepts. Now let's talk about threats, vulnerabilities, and mitigation. So 22% of the exam talks about threat actors and motivation. So for your exams, you want to understand what are the different kind of threats and what might be the motivating factor. What is like telling them, okay, I think we should do this. I think we need to do this. So different threat actors are going to be motivated by different things. So we normally say that for you to have an attack, you need to have a threat, you need to have a motivation, and you need to have a vulnerability. If you don't have these three items, you're not going to have an attack. So an attack is going to be based on a vulnerability, a motive, then a method. Let me go again. A motive, a vulnerability, and a method. So if you have these three things in your equation, equals to an attack. If you have a motive and there's no vulnerability, you cannot have an attack. If you have a motive and you have a method, you can't even have a method if you don't have a vulnerability. So the approach always is, what is the motive? I want to get access to this. Now the question is going to be, for that particular motive, do I have any window? Is there a vulnerability for that particular motive? Once a vulnerability is seen, then the question is going to be, how do we exploit that particular vulnerability? So that's actually the chain of command when it comes to exploring or exploiting vulnerabilities. So you have different types of threat actors, you have nation states, you have hacktivists, people that are actually trying to pursue a cause through cybersecurity means. Okay, you don't want maybe gender-based kind of activism or country-based kind of activism or a particular cause, a particular kind of concern, but they're trying to use hacking to actually achieve that. You call those guys hacktivists. Then you have insider threat, one of the most terrible form of attack. Then you have organized crime, then you have shadow IT. Shadow IT has to do with something that we call using tools, using softwares that is not approved by the IT head or the IT department. Take for instance, you're using a software that we didn't approve. That cannot become a means through which your systems can be vulnerable to attack. We're not using a particular browser it's not approved to be used. I remember when I was in banking, it used to be Internet Explorer or nothing else. Chrome was just gaining grounds. What was it called? Firefox was just gaining grounds, and because you have a lot of people using Chrome extensions, especially Firefox extensions, to perpetrate a lot of things, then the bank would typically say you use Internet Explorer. Aside that, you cannot use anything. And at times it was boring. It was a little bit kind of. Now you have Edge. You have the versions have updated. Like, but 20 years ago, it wasn't so. It was not as fast as the other what's it called, browsers, so to say. A lot of people say, okay, if you do a speed test, which is going to be faster? Is it Explorer? Is it Opera? Is it Chrome? Is it Safari? Is it what? But the bank was most concerned about threats that is going to come through shadow IT, through you using softwares that is not approved by the bank, right? Then you also have these threat actors are going to have some kind of attributes. So what is going to be their attributes? Are they internal? Are they external? Do they have resources? The amount of funding they have will tell their level of sophistication. Then what is their motivating drive? Is it that they want to do data exfiltration? They want to collect data. When you say data exfiltration, you're trying to say you want to collect data. Typically, a breach is going to happen. Then espionage, are they trying to spy? Is it for financial gain? Is it for revenge? Is it for war? I remember a client one time that had an attack. We're trying to rescue the website, fix the website, get the website up and running, try to do vulnerability assessments, try to do digital forensics on the hacked website. And he was sharing and said, okay, he knows this is going to be from a competitor, maybe a competitor trying to do a revenge, right? So there's always going to be different reasons why you have different types of attack. Now, understand that these attacks will come from different surfaces. When we say attack surface, we mean what are all the different inroads into our application. And that's why, as much as possible, IT analysts, security analysts wants to reduce the amount of attack surfaces, or to put it this way, we want to ensure that if we cannot reduce them, we ensure we have controls across all our attack surfaces. What is an attack surface? How do I get to use your system? If you have a website, an attack surface is going to be the login page, right? It's going to be maybe a mobile app that grants access to the website. So any way you can communicate with that particular digital asset is going to be an attack surface. If you have a system, the USB drives is going to be an attack surface. If you have a camera, it can be an attack surface. If you're connected to internet, it's going to be an attack surface, because that is where and how attackers can get to you. And that's why we say that the most secured internet, or the most secured device or system, is that system that is not connected to the internet and that is not interacting with anyone. Yes. So, but you know, it's not really possible to have such kind of system. That's why you see when people want to stay secured, they use devices that don't have access to the internet. So you have unsecure network, human vectors, right? Because this can lead to all of this, right? So the more attack surfaces that you have, the more vulnerabilities that you have. So what are the different kind of vulnerabilities that you can have? So you have quite a lot of them here. So you have vulnerabilities that have to do with the software, your application. Within your application, you have those that can be memory injection, buffer overflow, race condition. Race condition, if you are new to this term or this concept, it has to do with software developers not checking sequence of actions. You're not checking sequence of actions. It's just like saying, okay, you have a bank software and somebody have $1,000 and the person transfers $200 out, and the person is coming back to transfer $2,000. Now, risk condition is going to be where the developer does not check the account balance before trying to initiate another transaction. So it's like you are running. If you have the other guy trying to take over from this other guy, if you don't do a proper pickup, then you'll not be able to continue the race. So if you don't do an account balance check properly, what is going to happen is that there's going to be a mismatch, and that's a vulnerability, right? So you want to ensure that you do a time-based check in time, to ensure that at every point in time, you know what is on ground before you now take the next action. That way you create systems that are a little bit secured. Now you have those that are operating system tied, then you have those that are web-based, SQL injection. In the channel, I have a comprehensive playlist on the Cisco Ethical Hacker. I did a lot of exercise, that's cross-site scripting and SQLI injection labs. You can check that out and familiarize yourself with some of these hands-on. Then you also have those vulnerabilities that are based on the hardware or firmware, or those hardware that are now old, so end of life, those that we've discontinued the support. So you call those kind of items end of life hardware. Then for virtualization, VM escape is where a vulnerability escaped a virtualization system and gets into the host system. So because in virtualization, we're trying to say we have our hardware, let's say a HP device, then we have a, what's it called? We have something that looks like, let's say, our operating system. If we have our operating system, then we now have our VMware. We can have, let's say, VMware or any virtualization software. Then we can now have softwares, right? We can now have stuffs. So VM escape is going to be where you have a vulnerability here and is now escaping into the operating system. So that's what you call a vulnerability. So how do you control this? You want to ensure that you have proper patching of this operating system. You want to ensure that you have firewalls. You want to ensure that you have other controls that is going to protect this particular operating system from all the associated vulnerabilities within this sandbox. Because most virtualization platforms or systems are used for testing, for sandboxing, for doing quite a lot of things. So you don't want that vulnerability to go into the host system, right? So you also have some vulnerabilities that are cloud specific, that are cloud based. Then you have some that are supply chain based, because if your supplier have vulnerabilities at their own end, imagine you are an eatery or a restaurant, and logistics is taken care of by third party, or let's say payment is taken care of by third party. So if they have vulnerability, invariably you have inherited that vulnerability. Or you can have some kind of vulnerability that is associated with misconfiguration, or you have a mobile. Imagine, for instance, you have a system, you have a software, you have a hardware. Aside just having misconfiguration, you are using default systems. So if you're using default system, is a type of misconfiguration. Or you are sideloading, jailbreaking a mobile device. That's to say that you want to be able to install softwares that won't go through if you were not jailbreaking. Jailbreaking will mean like having to do root access. Most devices can allow you to do root access. When you have root access, then you cannot install anything. So that can lead to vulnerabilities, because most softwares can now install without actually doing security checks. But if you install softwares coming from Play Store, Apple Store, actual vendor stores, then they will do the check before allow you to install on the device. But if you jailbreak the software, if you jailbreak the system or jailbreak the mobile device, then those checks will not be done. Any software you install will just go through. Then for zero-day attacks are attacks of vulnerabilities that come about by the owner of the software, the owner of the application, not being aware of that particular vulnerability. That's why most big software vendors have what we call bug bounty. So for bug bounty, they will tell you, if you tell us so vulnerability within our application, our systems, then we'll pay you so amount, because we don't want the vulnerability that we are not aware of, right? and a bad guy is aware of that, it will cause us more harm. It's better that we pay people that are legitimate, that are ethical hackers, to like try to check our systems and see what vulnerabilities. If we see it and it's an actual vulnerability, then we pay. That's called bug bounty. Okay, so that's about for the different types of vulnerability. So we also have indicators of malicious activity. So here we want to be able to analyze. So what tells that we have a malicious activity? So quite a lot of things. Account lockout, concurrent session usage. Imagine I am logged in now and another person is still logged in with the same credentials. So there might be something fishy there. Out of circle login, missing logs, resource consumption. Let's say you are having tons of usage or traffic, internet traffic, more than usual. You call that resource consumption. So you want to be able to know when you have an indicator of compromise. You want to know when you have an indicator of a malicious activity. So for exam questions, you're going to see things like, okay, you have so and so is happening, so and so is happening. So what kind of malicious activity is that, right? Or what should you be doing in terms of control? Aside understanding these vulnerabilities, you should be able to understand how do you mitigate, because the module 2 is not just about you understanding the threats, the vulnerabilities, and the mitigations. You should also understanding how do you mitigate, how do you ensure that you don't allow this to happen. So you have segmentation. Segmentation have to do with you keeping things separate, or we could say separation of concerns. For a software, you want to keep maybe different aspects of the portal separate. For a network, you want to keep the demilitarized zone, you want to keep the user end zone, you want to keep critical zone, you just want to have some kind of separations. You want to have some kind of access controls, and the access controls, you want to tie them to what we call, maybe if it's a network, a VLAN. A VLAN is where you have some kind of logical, something like this. You have a switch, then you want to separate the switch logically. If you cannot do it in a VLAN style, you can have separate switches, configure them in such a way that they are different, right? So this can be IT, this can be marketing, this can be finance, this can be C-level executives. So you want to have them separated. That's what you call segmentation, because when you separate them, somebody here will not be able to have access to here. If this is down, then this also is not going to be down. That way, we ensure that we have a better secured system. Then you want to have application allow list. That's one way you can have vulnerability being mitigated. You want to have a list of controls, list of softwares, list of applications, list of items, list of IPs. So how do you do that? You can map MAC addresses of different systems, and the rest is going to be denied. So if you're not within these IP addresses, or if you're not within these MAC addresses, we will deny you. Then you want to have isolation, patching, monitoring, least privilege. You can also do some kind of hardening, right? Okay, that's going to be that for mitigation techniques. So attack types. So the different kind of attacks will tell different kind of mitigations you're going to be doing. So you have what we call malware. So malware is the umbrella word for every software that's going to cause system malfunction. So when we say system malfunction, when things don't go the right way, we call that a malfunction. So what makes that to happen is what we call a malware. So there are several types. It can be a ransomware, a Trojan, a rootkit, a spyware, all of that. Now, you can have some vulnerabilities for physical vulnerabilities. That's to say, let's say we have a brute force attack, or we have our RFID cloning, or we have a situation whereby people get access through because our controls are not rock solid. So that's why when you put controls, you want to make sure that you have multiple controls. At times we call it the defense in depth. You have multi-layers kind of controls. You don't just have one type of controls, right? You can have physical, you can have technical, you can have administrative. You can have multiple controls just to guide one asset. And of course, before you do that, you do what we call risk assessment. So you also do you check the value of the asset. If lost, that will tell the amount of investment you should be doing on that particular asset. At times we call it security, what's it called? Return on security investment. So imagine you cannot be saying a digital asset just costs $1 and you're investing $10,000 on it. So you want to check what is going to be our loss financially, our image, our brand image, our credibility, our customer base. You want to quantify that. That will tell how much. So a digital asset might not cost so much, but because of what is going to go wrong in terms of our brand image and perception, then we can use that to quantify and know how much kind of investment we can do to secure that system. So we have other types of attacks. So we have those that are associated with networks, application, cryptographic, and of course password. Okay, that's that for module 2. For module 3, where we're looking at security architecture. So here we have a lot that have to do with architectural models. So for our infrastructure, what are some concepts that we need to understand? Because in tech, in cybersecurity, you first want to understand what you're protecting before you can protect it. It's as simple as that. That's why I would normally advise, if you want to do cybersecurity, have a little grasp of cloud, have a little grasp of hardware, have a little grasp of some little programming, have a little grasp of networking. These 3, 4, 5 areas will give you some good foundation so that when you're trying to understand this concept, it makes sense. And when you're trying to say, okay, how do I protect these items, it makes a whole lot of sense. You cannot protect what you don't know. You cannot protect what you don't know about. So for cloud, you're expected to understand some of these concepts. So how do we deploy tech? We deploy tech in the cloud. And there's what we call responsibility matrix. And responsibility matrix, we're just saying that if we have our digital assets in the cloud, if we have our websites in the cloud, if we have our network in the cloud, if we have storage, it's as simple as Google Drive. If we have that in the cloud, who is going to be responsible for what? If it's a hybrid situation whereby we have some things physical and some things in the cloud, who is going to be responsible for what? So that's what we call the responsibility matrix. In the training series, I've explained that. You just have to say, okay, for our data, for our network, for our physical security, who takes care of that? One thing you want to understand in the responsibility matrix is that for cloud infrastructure, your data is fully your responsibility. Data, very, very important as regards your responsibility. Then we have infrastructure as a code, you have serverless, you have network infrastructure, you have containerization. So containerization is an outshoot of virtualization. And of course you have Internet of Things, ICS, access that. Okay, so the next item is going to be consideration. So for consideration, when we look at some of these architecture models, how we deploy stuff, we want to look at availability, resilience, because we want to ensure that the way our systems are deployed are in such a way that they are available. There's resilience. There's people can actually have access to items when they need to have access to them. Then we have cost. So cost have to do with responsiveness. Then scalability, ease of deployment. Then risk transference. So because in risk management, using the risk management framework, you can check out the NIST risk management framework. There are 4 things you can do when you have a risk. You can accept it, you can transfer it, you can mitigate it, you can, what's it called? I think the 4th one, you accept, you what's it called? You accept, you transfer, you mitigate. I think I skipped to the last one. So one of it is transference. So you can actually transfer a risk. When you transfer a risk, you can transfer the risk, let's say an insurance company. You can transfer the risk by getting somebody to take care of that, right? So it's a way to actually ensure that you have a very sustainable system. Then patch availability is something you want to consider. You don't just want to get to use an IT system if you're not sure that it is going to be sustainable for the long time. That's why you see vendors, we normally have their systems, and with time they will discontinue patch, because if you don't have patch, the patches will typically contain security updates, we contain stuff that will make sure that the system keeps working. So aside security, you might have little additions that ensure that it is usable by the users. So you want to also consider all of these items. Then we have security principle for enterprise infrastructure. So if we want to have an enterprise infrastructure, there are a few things we want to be very certain about. We want to consider them. So device placement, security zones. So where do we place our devices? Placement of devices are very important, especially things like firewall. If I have 100 systems like this, I have my internet this way, where do I place my firewall? Here or here, right? Or do I put a device here and place my firewall here? So where do I put that? You have security zones. Within this enterprise, you can have different security zones, that is different end devices segmented into different security zones, and they can have different security controls depending on the risks that is associated and the value of the assets. Another thing also you want to look at is failure modes. Should it fail open or fail closed? When we say fail open, what we're trying to say is that something breaks down. Should it break down and allow access, or should it break down and break down and ensure that nobody can have access? Imagine you have a login system. If that login system is going to fail, is it going to fail and becomes vulnerable, becomes open so that people can have access to login? Or is it going to fail and is locked up or is closed? So these are different concepts. Then network appliances, we have jump server, proxy server, IDS, IPS, intrusion prevention system, intrusion detection system, load balancers. For exam in the curriculum explainer for the 701 on the playlist, I've explained all of these concepts. Port security also, firewalls. You want to differentiate between a UTM and a new generation firewall. You want to be able to know, and a WAF, you want to differentiate and understand these different kinds of firewall and which one does the best in what kind of situation. Now let's look at secure access communication. So for secure access communication, if we want systems or we want people to be able to have access to enterprise or have access to digital assets, and they are not within the same building, or they are in the same building, or they are going to access it through a remote means, what are the different ways they can have secure communication? What are the different ways they can have secure access? So we have VPN, we have TLS, we have SD-WAN. So SD-WAN is software defined wide area network. So this is something that is getting so common for the past so many years now. You have networks and not just managed using hardware. We now manage our networks using softwares. So that's what you call software defined networking. So imagine you have a WAN and you can shut down the entire WAN using softwares. Imagine you have a network and you can reboot the entire hardware devices using software. So that's what you call software defined networking. Imagine you can sync time, you can install patches, you can do a lot of things via software. Then of course you have secure access service edge. So edge are going to be devices within your network that is going to typically communicate with your cloud service provider or other areas of your network. Now, another one we're going to talk about is going to be concepts and strategies to protect data. So how do we ensure that we protect our data? So we have different types of data: regulated, trade secret, financial, PII, all of those kind of data. We first have to classify our data before we can now protect them. And in trying to classify this data, there are some general considerations, right? That data can be at rest. The data can be in transit. At rest meaning that we just have data on our PC, data in our folder, data in our phones, data in a file. That's the at rest. In transit, data going from point A to point B. You are transferring data from point A to point B over a network to your cloud service provider, to your host, or in use while you are actually working on that particular file. These are the different states you have in data. So your different states will tell the kind of mitigation or the kind of control you should implement. And that's what we call data sovereignty. Data sovereignty have to say that, and this is part of the GDPR, General Data Protection Regulation, is an EU policy that's adopted by most countries. We want to say that people should have and own their data. Data is owned by somebody. And also countries will also want to make sure that data lives where the jurisdiction where the data was created or the owner of the data. That's why you see that most countries will not allow you to be using their data while you are elsewhere. So you need to have a company within that country. You need to pay tax. Then you need to comply with the data governance policy, the data protection regulation of that particular company. Big companies like Facebook, X, Google, they face these issues because of the principle of data sovereignty. And of course, geolocation. Data can be in several areas. And you find this in cloud computing, where you see you have a CDN, a content delivery network. A CDN is going to place your data in several parts of the world to ensure that data is closer to individuals. It makes for easier latency. Imagine you're in the US and your data is in a server in the UK. It's taking a longer time for you to be able to pull that data, or you're accessing a website and it's somewhere very far. It takes a longer time. But if you have geolocation, if you have data within your country, within your environment, it makes it faster. And CDN helps us to do that, powered by cloud service providers. So what are some methods to secure data? So we can do geographic restriction. We can say, okay, if you're not within certain geographical area, you cannot access this data. We can do encryption. That's to say that we can say, we want to ensure that if you are not the owner of this data, you shouldn't see the data in plain text. It should be encrypted. Hashing. We want to ensure that we hash the file. We want to have a digital signature that tells us the hash value of that file, so that if we check the hash value at another time, we can tell if somebody actually tampered with it. Then you have maxing, tokenization, obfuscation. So that's where steganography comes in, where we want to make sure that we max, we obfuscate that particular data so that it's not noticeable, it's not seen. Or at times we can do what we call representation. So you have name of somebody, but you don't use the name of the person. Use something else that represents that particular stuff. It's a way to do some obfuscation. It's a way to mask the actual owner. These are ways you can secure data. You can also do segmentation. You can do permission restriction. You restrict people from having access to what they're not supposed to have access to. Now the last one in module 3 is going to be resilience and recovery. So you have some kind of incident response concepts coming here. Incident response, you have some concepts about business continuity coming up here. So for resilience, we're trying to say, if something happens to us, if we have an attack, how do we ensure that we are still active? How do we ensure that we still keep moving on? So things like high availability, load balancing. What's a load balancer? What is clustering? What are different ways we can do clustering? Can we have a load balancer to ensure that if we have 1,000 traffic coming to our application, our network, can we load share rather this traffic to different servers so that doesn't get overwhelmed and crashes? Can we also have clusters? Can we have cluster A, cluster B, cluster C, so that if we have a failover, we can pivot into another cluster to take care of our traffic? Then we have different kind of sites. We have what we call the hot, cold, warm site. We have what we call geographical dispersion. A hot site is that site that we're going to have, and if something happens, we can get back on track immediately. A cold site is going to be that site that typically don't have the servers, you don't have all of those things right there. So it's going to take a longer time for us to recover. A warm site is that is just going to have basic necessities, right? So for your exam, you want to be able to differentiate and say which kind of site should we have depending on the scenario that is being granted or given to you. Then capacity planning is so important. In tech, we normally say people, process, technology. People meaning who is going to manage this. Technology meaning how do we do that. Process is going to be what and what are we going to be doing. So for capacity planning, we should be looking at people, we should be looking at technology, we should be looking at who is going to manage all of this. We should be looking at what kind of technology are we going to deploy. Then in trying to make sure that we have resilience, we have to test what we have actually planned out. So you have different types of tests. You have the tabletop, you have the failover, you have the simulation. At times we call them playbooks in forensics. So we want to make sure that though we say we have a site that if something happens, we can use the other one immediately, we want to test it out. In testing it out, of course, understand that you should have permissions, you should do that at downtimes. These are to ensure that when the actual stuff happens, you've actually test run it and you are going to be safe. You should have backups, and your backups can be on-site, off-site. If it's on-site, what it means is that you have a faster time of recovery. If it's off-site, what it's going to mean is that it's going to take you a longer time of recovery. Then what's the frequency? Is it incremental? And you should ensure that your backups also are encrypted. Another concept about backups is snapshots, right? Snapshot is just a time-based replica of your image, or a time-based replica of your asset. If you have a mobile phone and you do a snapshot of that mobile phone, so everything in that mobile phone, the state, the apps, the software, the messages, everything, you have it. If it's a PC, same thing. If it's a server, same thing. Then you cannot talk about resilience without talk about power generations, UPS. Okay, that's the end for module 2. Let's talk about module 3, where we're looking at security operations. So security operations was added in this version 7 of the exam. So you have security techniques for computing resources. You have hardware, you have software, you have data access management, you have several vulnerability management activities, you have security alerts, you have monitoring concept, very important concept in terms of tools. If we want to do monitoring, how do we do that? Do we use a SCAP? Should we use a SAM? Should we use an antivirus? Do we use a simple network management protocol, traps, or a NetFlow? Should we use a vulnerability scanner? So all of this is going to be dependent on your vulnerability, on cost, on risks, on the kind of controls that you want. And the kind of activities that you're going to be doing is going to be log aggregation. Because if you want to do forensics, you cannot do forensics on nothing. You're going to do forensics on what has happened. And one way to keep track of what has happened is logs. Right? You want to have a situation whereby you can do alerts. Right? Okay, let's look at IAM, very important concept, identity and access management. For IAM, you want to understand provisioning and deprovisioning. Provisioning meaning you onboarding, giving people access to something, a system, a cloud application, a network, that's provision. When should you deprovision? When people leave, when people resign, when people no longer work with you, you want to deprovision. So identity proofing, you want to ensure that the identity of whoever you want to grant access to, it's done. Federation, single sign-on. So this is a concept where people can use one login system or one user access system to log into multiple systems. That's why it's called federation. Like in most countries, federation. When we say federation, that's the top. You have different states, you have different jurisdiction. If you have access to this, you have access to everything. So federation single sign-on is when you use your Gmail, for instance, and you can have access to multiple websites. It comes with vulnerability. So when you're granting access, that's one way identity and access management can be done. Same thing with access control. So you have different types of access control. You want to understand that you have access controls that can be either mandatory, discretional, role-based, rule-based, attribute-based, and you need to understand the concept of least privilege. For role-based access control system, what you're trying to say is that you want to give people access based on their role. Maybe you have finance, HR, management, user. These are different roles. So you want to grant them access based on their role. So their role will tell what kind of access they should have. For rule, you want to go by certain rule. So you can say, okay, at midnight, at social time of the day, at different kind of rules you can have. Then for attribute, it can be based on the kind of task or the kind of things you want them to do. So you should be able to understand the different types of access control. Then multi-factor authentication is a very straightforward concept. Then you also have password concept, best practices. How should your password be? What should be the password policy? What should be the length of the password? How should you use password managers? You also have what we call passwordless systems. I've used a few of them. What the system does is that you're not going to be asked of any password. You try to get access to the system, you're told to enter your email, you put in your email, they verify your email. Going forward, if you want to have access to the system, just put in your email, they will send you a link to your email. Once you click on that link, you get access to the system. That's one way to ensure that people don't break into systems because there's no longer a password. But it has a downside. If somebody have access to the email, what it means is that the person can also have access to that particular platform. Okay, so we also have automation and orchestration. Automation and orchestration, very important. So in automation and orchestration, we're trying to say, how do we ensure that we have a seamless system across board? So we have use case, you have guardrails, you have integrations. When you have APIs implemented into your system, what's an API? An API is just a way for two systems to communicate. I have a website, I want to collect payments. I'm not the bank, I'm not a payment processor, but I can use another payment processor on my system. What have I done? I've integrated an application programmable interface. So another thing that has to do with automation orchestration is when we have some kind of baselines. So baselines are what's our least acceptable controls, right? Another thing you want to also consider is to secure, or rather to scale securely. Then what is going to be your reaction time if something happens? That's where automation comes in. Because it's one thing to have security controls in place, it's another thing to ensure that you can actually scale in record time. Then another important concept is single point of failure. A single point of failure is going to be a situation whereby you don't have backups, you don't have alternatives. If anything goes wrong, everything is down. So those are important concepts, and you shouldn't implement systems that just have like one single point of failure. Then incident response activities. Incident response is what you do after you have an attack. But before you can do that, you have to also prepare before the attack. So it's what we call digital forensics and incident response. So in digital forensics and incident response, digital forensics comes later on after the attack. But before you can even do that, the CIR team, that is the incident response team, or the cybersecurity and incident response team, people have to be trained. People need to know what to do when this happens. People need to know who to call when something happens. People need to know all of the details and the different types of attacks they might have and what they need to do. So you have different kind of activities that happen as a result of an incident or to respond to an incident. So one of the first thing is the process. So you have to prepare. So you prepare for an incident by making sure that you have an incident response policy, you have an incident response plan, you have a team on ground, you have, for different scenarios, what are you going to be doing. Then you want to ensure that you have detection in place. You want to have software, you want to have hardware, you want to have principles of what to do to be able to detect an incident. Then you want to have a way to actually contain, like I remember a particular time when you have a network infected by malware, one of the first thing you want to do is to actually contain. Then you eradicate, then before you can now do recovery. You don't lump up everything together because you want to maybe mitigate the attack. So you might have to do some kind of containment, you might have to do some kind of eradication, and at times you want to do some recovery from the backup that you have. And at the end of the day, you want to ensure that you have some documentation done about the lessons that you've learned. Then you want to be able to do what we call root cause analysis. So what happened? I remember a certain time a client had one of his server down. And one of the things you are going to do when you have that kind of issue, you want to be sure that, or you want to be certain to see if it's a denial of service attack, a distributed denial of service attack, a malware attack, you have some threat actors responsible. You want to be able to tell why. Root cause analysis is so important, and when you know the root cause, it can help you in future mitigation strategies. Then of course you have threat hunting, you have digital forensics, very, very important concept there. On the channel, I have a complete playlist on incident response and digital forensics, so you want to check that out. Now, when you're doing investigation, your investigation is going to come from most of the sources. Like I said, if you do digital forensics, what are you going to be checking? It's going to be your log files, it's going to be your packet captures, it's going to be your reports, it's going to be your scans. So these are going to be the sources of your investigation. Okay, that's that. Let's look at the very last module, which is security program management. Most of the times, if you want to have a secure system, it's not just by installing software, installing hardware, all of that. You need to have a kind of a program. You need to have some kind of governance to it. You need to have some kind of C-level executive input towards what the goal is. What the goal is going to tell what the sub-goals are. What the sub-goals are will tell what kind of security posture you can have, and that's what's going to tell what kind of security governance you can have. So what are some of the elements of your security governance? So it can be your guidelines, your policies, your standards, your procedures. You need to also consider when you're doing these regulations. So the regulations can be external. It can be that, let's say it's a bank now, your country's central bank is going to have a regulation towards security. Most countries have cybersecurity program for banks. They have for fintechs, they have for educational institutions, they have for government ministries, agencies, and departments. So some of these things are things that the internal team need to bring into what they are doing and adapt it to the guidelines, the policies, the standards, and the procedures that they have. Then, in whatever kind of governance document or policy that you have, you must versionize it. You must also even monitor it, in the sense that if you have a set of things you want to do as your policy, every year, every 2 years, every 6 months, depending on what your policy says, you should review this document, because if you don't review them, you make it possible that you have vulnerability just because you didn't take care of certain things. Then you should have a governance structure. A governance structure is going to be a board, a committee. A committee can just involve HR, CTO, CEO, maybe some external vendors that are party to some of your deployments. You can have a kind of set of persons that will actually contribute to your security governance. You can look at the General Data Protection Regulation. It addresses a lot about the who an owner is, controller is, and custodian. So this has to do with data. Now, risk management is very important. Remember the last time I talked about risks. So in your risk analysis, it can be a quantitative risk, it can be a qualitative risk. And when you're doing your risk identification, it can be something you do ad hoc, very, very smart, very, very sharp, or something you can do continuously in a regimented format. Every company is going to have some kind of risk tolerance. They're going to have what they can't take, so they cannot take beyond, right? They're going to have their appetite. Some companies can take some certain kind of loss, they can take some kind of risks, and you're going to have different type of strategies, right? I mentioned them. I said you can transfer, you can accept, you can avoid, or you can mitigate. I think the one I forgot was avoid. When you say you avoid the risks, what it means is that you no longer even want to go into that venture. Let's say you want to deploy a software and you're trying to do risk management, or you want to integrate a third-party component to your software and you're trying to do risk management. Now, if you see a particular risk that might lead to a lot of loss because of a cybersecurity breach, avoiding the risk means that you no longer want to run that software. Mitigating means that you now put in controls. Accepting means is that you now accept it as part of a loss that might occur if something goes wrong. Transferring the risk means that you now want to give it to a third party to ensure, or you want to transfer that aspect of that particular software integration to somebody else so that the person now manages that risk. For example, you want to be able to differentiate recovery time objective, recovery point objective, mean time of recovery, and I think this should be something that has to do with let me check that up. MTBF. Mean time to recover, then mean time between failures, right? So every company is going to have these metrics. So these metrics will tell what should be accepted and what shouldn't be accepted. So you have root time recovery, you have recovery point objective, you have mean time to recover, then you have mean time between, what's the word again? Between failures, right? So you want to keep this very, very short, your time between when you failed and when you come back on track, the time between when you failed and when you recover. These times you want to keep them as close, as short as possible. Of course, you have third-party risk assessment and management. You can decide to say, okay, you want to get somebody else to come and check you. One way to do that is to conduct a pen testing, is to do due diligence, is to make sure that people don't have conflict of interest. And you have different types of agreement. For example, you want to be able to differentiate between a service level agreement, a memorandum of understanding or of agreement, a scope of work, or a master agreement. You want to understand what is an NDA, a non-disclosure agreement, or a BPA. So these are concepts and different kind of agreements that tells when you bring in a third party, what kind of agreements can you have with them? Okay, another important thing we're going to be looking at is elements of effective security governance. So security governance are going to involve, like we said, external, internal. If you have non-compliance, what's going to be the fine? Like most countries, most regulators, they have fine when you fail to meet some kind of compliance, right? So you also have compliance monitoring, due care, due diligence. You want to know the difference. Then for privacy, you want to ensure that local laws, national laws, global laws, you want to comply to them, right? And if you study the GDPR or the National Data Protection Regulation of your country, you will get to grab most of this concept as it adapts to your country. Or if you study the General Data Protection Regulation, you will understand concepts like the right to be forgotten. Right to be forgotten just have to say, okay, if I have data or I give you my data, I can say I want the data to be deleted. It wasn't like that up until 2017, 2018, where we now had the General Data Protection Regulation. Now, you have different types of audits, right? Different types of audits. So you have an attestation to attest that you've met some certain kind of standards. You can have some kind of assessment that is internal. So your internal team can do those audit checks. An audit is just to see if you are following standards. It can be self-based. Then you can have external that are by the regulator, by an examination body, or by an independent third party. Then you also have what we call penetration testing. So penetration testing, you have different types of penetration testing. So you have known, partial, unknown. When we say known, partial, unknown, it just have to do with the kind of details that is being given as regards the test. If I say come and do penetration testing for my software or for my website, and I give you a lot of details about the software, the IP address, the server it is on, the uptime and the downtime, all the different attack surfaces. If I give you most of those details, it's like a partially known environment. If I give you a lot of details, things like user credentials, at times we call that credential testing. So it's known as a known environment. So, but if I don't give anything, like making you want to act or work like an external or a black hat hacker, or someone that doesn't have idea, for you to just test my system, it's called unknown environment testing. And reconnaissance, you have two types. You have the passive and active. So if I am trying to check details about a server or an asset I want to get access to, and I do that without actually actively communicating with that particular service, is called passive. If I do an actual communication with that particular asset, is called active. Then if I don't, it's called passive. Take for instance a VIP. Maybe somebody was contracted to do online reputation management. You want to see what vulnerabilities there will be for that VIP. If you start searching on social media platforms, start doing what we call OSINT, open source intelligence gathering, you classify that as passive reconnaissance. You want to know the person, the age, where the person works, the companies the person is associated with. All of that is passive reconnaissance. It's active when I start doing things like a telephone call, things like visiting the site, things like trying to do scan on the network. That you call active reconnaissance. Now, very, very important is security awareness practices. Now, people should be aware. Most of my students, I will make them to build a phishing system they can use to do security awareness training, so that you can detect to know if people are vulnerable to an attack or not. Okay, I think that sums up the entire content for the security plus certification exam. See you on the next one. In the next one, we'll bring to you exam questions to test your knowledge to see if you can actually, if you've actually understood the concept about the 701 exam.